Okay, 7.1, B as in boy. We're in example 6, top of page 578. So let's continue on, completing the square. We have 3x squared minus 8x plus 7 equals 0. All right, so here's the bad news. Almost all the time when you're dealing with completing the square, you're going to be dealing with fractions. So if you're not good at fractions, something that's probably good practice for. If you hate fractions, well, sorry guys, you're kind of stuck with them. All right, so one of the things with completing the square is you cannot have a lead coefficient. You cannot have a number in front of the x squared, okay? Doesn't work. So we can't factor it into two binomials, so we're stuck with getting rid of that 3. How do we get rid of that 3? It's very easy, but it makes things messy. You just divide everything on both sides by 3. And because anytime you divide 0 by anything, you end up with 0. You really don't even have to show that. So what we end up with then is this 3 cancels. All right, so now we're ready to complete the square. All right, so let's write this. Subtract 7/3 from both sides and leave that blank there. So remember on the last problem, I gave you a little hint that helps you to find half of any fraction. You double the denominator. So 8/3, half of that is going to be 8/6. And then to find this number right here, remember what we do? We have to square it. So that ends up being 64/36. And if your math skills are sharp, you can reduce this to 16/9. 4 goes into 64 16 times. 4 goes into 36 9 times. So instead of adding 64/36 is what we get when we square that, we reduce it to that and put that here. And we have to add it to the other side as well. Okay, so factoring that is a piece of cake because we just draw that, we do an x, we bring down the sign, we put a 2 up here, we take the square root of that, which is 4/3, and we're good there. The pain in the neck is adding this stuff together. Need a common denominator. We're going to leave the 16/9 as it is and change that 3 to a 9 by multiplying it by 3, which means we need to multiply the top by 3. So that gives me x minus 4/3 quantity squared equals -21 plus 16 is -5/9. And it would be nice if we were, let me get some of this out of the way. Be nice if we were done, but we are still working with, let's get rid of some of that. We're still working with this because we have that doggone squared sign. So now, square root of both sides, put a plus or minus there. And now we have x minus 4/3, got rid of the squared sign, equals plus or minus square root of -5/9. Yay, square root of 9 can be changed to a 3. Because remember what we were doing before, I'm going to write this out, is that's the same as -5 over the square root of 9. So the square root of 9 is 3. So we already got rid of the denominator having a radical sign, and that will happen because your denominator will always be, you'll always be able to take a square root of it, because what you did is you took this and squared it. So you should always be able to take the square root of the denominator here and get rid of the radical sign. So that's kind of a nice thing to to have happen. All right, so let's keep going here. We're going to add 4/3 to both sides and end up with, it appears to be a mess. It is a mess. Okay, and now that you've been doing things with, let's get stuff out of here, imaginary numbers, you realize that what we have here is a negative sign in there. We've got to get rid of that negative in that radical sign. So let's rewrite this as, and remember, whenever there's a radical sign in there, it is an I. So we just take an I out, and our 5 then becomes positive. And we're good to go there. So what is our answer? X equals 4 plus or minus the square root of 5 all over 3, because we can combine these because we have the common denominator there. Now we have to write it as 4 plus square root of 5 all over 3, 4 minus the square root of 5 all over 3. So those are my two answers there. Whoops, I forgot. Sorry, my I. That I has to tag along. Probably wondering where that went. Okay, so obviously that problem could not have been solved. I mean, it was just a 3x squared minus 8x plus 7 equals 0. Obviously, we couldn't have put the correct numbers in here by doing it the old way. All right, so the completing the square always works, but it isn't always the most fun to do. So anyway, that brings us to the last two examples. And these are both story problem-ish. So example 7, we have a triangle. So let's see if I can draw a triangle that is. This is called an equilateral triangle because all the lines are the same. It's also an equal angular triangle because all the angles are the same. This one here's a 30 and this is a 30, which adds up to be 60. This is X. I'm just taking the picture that they give us here because they say if the shortest side of a 30, 60, 90 triangle is 1 inch. All right, so let me just draw in red here. This is a 30, 60, 90 triangle, and if you ever take trig, that's a very important triangle. So it's saying find the lengths of the other two sides. So I'm looking for the length of this one here, and I'm looking for the length of that one there. Okay, there are some rules with 30, 60, 90 triangles. That doesn't look like they're teaching you those rules. They're just asking you to figure this out. So what they did is they doubled this 30, 60, 90 because then if all the sides are equal, then the length of this side is 2, 1 plus 1. The length of this one is going to be 2, and the length of that one is going to be 2. So that helps us by making this as a 60, 60, 60 triangle and just showing that it was cut in half. Whoop. So if you remember Pythagorean, C being the hypotenuse, so we're going to write that as C is 2, so we're going to square that, and we'll call this A, and we'll call X our X squared, okay? So we pretty much have 1 plus X squared equals 4, subtract 1 from both sides, and we get X squared equals 3. Okay, so that being the case, let's take the square root of both sides. And we get X equals plus or minus the square root of 3. So X equals square root of 3, or X equals negative square root of 3. It can't equal the negative square root of 3 because the length of x cannot be a negative number. So the length of x is actually the square root of 3. All right, this is example 8, page 580. This is from the story problem that we had earlier in this section, where we had this chairlift that the vertical rise, the height that it went up the mountain, was 1,170 feet. So from the ground level to the top of the mountain is 1,170 feet. The length that it took to get that 1,170 feet is 5,750 feet. So you're traveling this far to get this high. They want to know how far it is along the ground to get from A to C. So again, this is one of those problems that you use. A squared plus B squared equals C squared. And if you remember, Pythagorean only works when one of the angles of the triangle is a 90-degree angle. And that's what this little square means, is that it's a 90-degree angle. Therefore, we can use Pythagorean. All right, A and B can be either, A or B can be either the horizontal distance or the height. That doesn't matter as long as C is this number here. So let's make A, the horizontal distance, what we're looking for. We'll make B the vertical rise, or the vertical height, and C squared 5750. All right. So now all we have to do is get our handy-dandy calculator out and get x squared plus 1,368,900. I did that in my head, right? And that equals 33,062,500. So we're going to subtract this from both sides and get x squared equals, I'm not going to write all that out, 31,693,600. Take the square root of both sides, and x equals plus or minus the square root of 31,693,600. And because we can't have a negative, when we take the square root of that, we get 5,630 feet. Okay. One of the things I need to look at is I need to compare that with that, because the hypotenuse, the A to B, has to be a bigger number than this one in order for it to be a true statement. So it is. So I'm good there. It's positive, and life is good. So that's it for 7.1.